All right, 6-2, inverse relations and functions. Essential question, why doesn't every function have an inverse function? Because life's not always fair. Fair is a place that judges pumpkins and pigs. All right.
It doesn't exist.
A relation is formed with any set of ordered pairs. And ordered pairs are x and y. And inverse relation is formed when x and y are switched. So if we have a relation, and this is called a function table. Well, it doesn't have to, it's a relation table, not a function table. -2, -1, 0, 1, 1, 4, 3, 1. Now, if we were to do an inverse relation, we literally just swap the x and the y's. So your y's would now become your x's, 1, 4, 3, 1. And your x's would now become your y's, -2, -1, 0, 1. So that's what an inverse is. You literally just swap your x and your y's. Inverse of the function, that's what the book put, but I guess it could be just a relation. The inverse of the function is written as f to the -1. So f to the -1 means it's an inverse. Not all functions have inverse functions. Not all functions have inverse functions. Alright, use horizontal line test to determine whether inverse function exists. If horizontal line crosses more than once, comma, space, inverse is, I'm going to write this as capitalized, not a function. And I'll give you a chance to catch up if you need to before I give you an example. And then I'm going to go ahead and turn my page. Alright, as soon as my smartboard opens, I don't know why it's opening on that screen, we will continue on. Hold on. Is not a function. All right, so for example, if we have a graph like this, that is a linear graph. It's a straight line. That sounds like a personal problem. It's right there. Okay. I'll enjoy spending the summer with you. All right, so if I have a horizontal line, how many times can a horizontal line cross a diagonal line? Only once at a time. So therefore, this one, its inverse would be a function. Inverse is a function. But if I have something like this, God bless you. That is a function in its current format, because if we do a vertical line test, it only crosses at one time. But if I do a horizontal line test, it's going to cross there, it's going to cross there, it's going to cross there. So is the inverse a function? Inverse is not a function, because it crosses more than once. Because later on in the period when we get to graphing them, you'll find out why. I know, it's fun. Can't have fun without function. Oh wait, you can. Can't have function without fun. There you go. No, I had a comment about the play, but it's recorded, so keep it to myself. Well, unfortunately, I'm doing a lesson right now. All right, so what it's asking you, is the inverse a function? Is the inverse a function? So on this one, we said the horizontal line tested only crosses it once. So for A, is the inverse a function? Yes. How about B? Y equals 2/3 x squared minus 4/3. First thing we need to identify is what kind of graph is B? Quadratic. So what shape is a quadratic? It's a U-shaped graph, correct? So it looks like that. It's a parabola. So does it pass the horizontal line test? How many times does it cross? it crosses once, it crosses twice, so that answer would be no. And because this isn't challenging enough, let's do a table. Yes, it is necessary. All right, for a function, I like to tell people functions are like vending machines. Elise, what's your favorite thing to get out of a vending machine? Anything? Soda, candies, chips? What kind of chips do you like?
Lay's.
All right, do you have a flavor of Lay's? Okay. Elise goes to the vending machine. When she pushes the Lay's barbecue, what does she want coming out? What if Flaming Hot Cheetos came out? Would that be acceptable? It would be for me, but how about if a jar of lemon juice came out? No, that would not be acceptable. So, the way it is right now, I know we have the same number twice, but the thing is these have different inputs. You're allowed to have the same output. But with the inverse, what happens to the x and the y's? We switch them, right? Yeah. So this time, when I swap it, Elise pushes her negative 0.0125, and she gets out her barbecue Lay's. She's happy. This time, she pushes her negative 0.0125, and prune juice comes out. Or a Mars bar comes out. What is a Mars bar? You're making stuff up. Yes. All right, so for C, this one's not. Because when we swap the numbers, it's not a function. All right, example 2. Let's move on. All right. It's because I have a negative 0.125, and when I swap them, the inverse swaps the x and the y. So now this becomes my input, and my output is negative 5. For this one here, your input is negative 0.125. Your output is 1. 1 is different than negative 5. So you have 2 outputs for 1 input. So far, it's not a inverse. Thank you for asking. All right, example 2. Find.
Is it yes or no?
It is no. Now let's get back to work.
It says yes.
It's yes, no, no. All right, Jonna, did you ask why this last one's no?
No, I said, is it no?
It is no.
Why is it no?
Because remember I said on an inverse you flip your x and your y's? So now my input is going to be negative 0.125, and what's my output? This time when I have negative 0.125, what's my output? So I have 2 different outputs for the same input, therefore it is not a function. Apparently the barbecue Lay's did not work right. Oh well. Alright, here we go. Ready? This time you push crisp and crisp comes out. This time you push crisp and almond comes out. So we're not happy about that. We have 2 different outputs for the same input. Stupid almond. That's why almonds are usually BOGO. Find the inverse. Here we go. This is a 2-step process. Or as John would say, process. All right, as her native Canadians would say, process. And there's no shame in that. Now, does he add an extra U to like color? COLOUR?
This is car.
He says pasta.
Does he say A?
Sometimes.
All right. Step 1, swap X and Y. So that's step 1. Step 2, solve for y. So it's a 2-step process. All right, so f of x equals 3x plus 2. F of x is the same as y. What? Okay. So step 1 says stop the x and the y, or swap the x and the y. So I'm going to literally swap them. X equals 3y plus 2. Step 2 says solve for y. So we need to get the y by itself. So I personally would get rid of the, you are correct. So x minus 2 equals 3y. We do not have the y completely by itself. So I'm going to divide by 3, divide by 3, divide by 3. There is a 1 there, even though you don't see it. So these 3's canceled out. Now the symbol we use for this, we're going to replace the y with f to the negative 1. X. So instead of function of x, it's the inverse function of x. And that would be 1/3 x minus 2/3. All right, the inverse of a linear function will always be a linear function. That would be some good information to know. All right, can we continue on now? We're almost done. Yeah, I usually go through more than one myself. Oh, I might have one or two. No. The graph of an inverse is a reflection, so go back to geometry, across y equals x. Sort of. I'll explain in just a second. All right, we are on example 3. Example 3. Graph y equals 3x minus 2 and its inverse. First thing we need in order to graph is a graph. So let's draw a graph, please. Yes, you is. I couldn't tell you.
What's the graph scale?
It's in my drawer. I thought about using it, but I didn't. Alright, so I'm going to choose multiple colors to graph. I'm going to do purple and orange. Why purple and orange? Because I can. Do I have to do anything to y equals 3x minus 2 in order to graph it? So I'm going to go down to put a point. That's my y-intercept. I'm going to go up 3, 1, 2, 3. That's my slope to the right 1. And now graph it. Well, this is actually Algebra 1, graphing straight lines. Hopefully 3. 1, 2, 3 over 1. Because remember, this is the same as 3 over 1. I don't know. Well, no, there's parts of Algebra 2 that I really don't. I actually really like that, when we had systems of equations and we had to graph 2 of them on 1 with the inequalities. I like that. I think it's pretty easy, and I get to draw, so it's a win-win. All right, congratulations. You just graphed y equals 3x minus 2. Now we need to graph the inverse. What was our two-step procedure for graphing finding the inverse? Swap x and y. So we have x equals 3y minus 2. And now what do we have to do? Solve for y. So add 2, add 2. Jonah, how long is this play? Is it 3 hours?
It's not a quick play. We don't spread math.
All right, so now we have f of negative 1 equals 1/3 x plus 2/3. I'm going to graph this one in orange. My starting point is up 2/3, so get approximately 67% of the way between 0 and 1. 67. Yep, that's pretty accurate, huh? So now go up 1 and write 3. 1, 2, 3. Draw your line of your inverse. And congratulations, you just graphed an inverse. All right, I'll wait. Now remember, right before this, we wrote that the graph in the inverse is a reflection over y equals x. Well, y equals x is a line that goes right here. So this would be the line that we are reflected over, the pink dashed line. It's reflected over that. All right, I went up 2/3 or 67%. And then I went up 1 to the right 3. We only need 2 points to draw a line. So I have my 2 points. Hands to ourselves, please. All right, here we go. Let's continue on. That is a linear function, so now let's do quadratic, and then we'll be done for today. Like I said, no homework for today. It could be, but it won't be. Why? Well, that's because you were doing the Wordle and connections instead of paying attention. So, that's not my fault. All right, where are you confused, Kate? All right, so you understand the purple line. We just graphed y equals 3x minus 2.
Yeah.
We went down 2, and then from there we went up 3 to the right 1.
Yeah.
I took my x and y's and swapped them because Jonah told me to.
What?
I was giving you credit for being correct. I know that's not a normal occasion, but... And then he said to solve for y, and I did. So I got rid of the minus 2, and then I divided by 3. So it gave me the inverse of f of x equals 1/3 x plus 2/3. So I went up 2/3, or 67%, up 1 to the right 3, and drew my line. The pink line is just showing you the line that it reflected over y equals x. Okay. Quadratic functions, the inverse. Ooh, that's almost in cursive, I'm sorry. The inverse of a parabola, is not, yes, that's all caps, I'm yelling, a function. Yes. Of course. Is not a function. However, I think that's called like an adverb or something. Comma space. I thought, except for however, I think it's special. All right, however, comma space. No, it's a conjunction. There we go. However, comma space, you can restrict its domain to make it a function. All right, so we are now in example 4. Graph. I almost feel like I should turn the page before I go. F of x equals x squared plus 1. All right, in order to graph it, what do we need? A graph. Good job. All right, draw a graph, please. All right, if we were to graph this one, is anything telling it to go left or right? No, it's just telling it to go up 1. Remember, your C term is your y-intercept, so it's going to cross at 1. And then it's going to go up 1 to the right 1, up 1 to the left 1. And congratulations, we just graphed a parabola. I went up 1 to the right 1. And then the next one would be up 3 over 1. And then up 5, and then up 7. But we're not going that far. That's what? Because they're there, you just can't see them. All right, so now it wants us to graph the inverse. So what do I have to do with my x and my y? Flip them. So x equals y squared plus 1. And then solve for y. So now I personally would get rid of the minus 1, minus 1. X minus 1 equals y squared. I believe the 2 is squaring, so the opposite of that would be square roots. So this is f negative 1 of x equals, it's a square root, so what do we know about a square root? There's how many answers? 2, because remember 2 times 2 is 4 and negative 2 times negative 2 is 4. The square root of x minus 1. I was just trying to think how I could explain this so that it would make sense to you. Well, you can graph square roots. Okay, give me just a second. What do you mean? I hate graphs too.
Are we restricted to domain?
Hold on, not yet. We will. To make it a function, we could restrict its domain.